Morning.
Hi,
Yeah,
morning,
great.
Kishan. Hi. So we're reviewing recent articles about application modernization, so we can distill insights from it and talk a bit about it. I have with me Kishan, the CTO of Eli5, who is a first-hand practitioner when it comes to software modernization and building software products. So we are reviewing a couple of articles. First article is this one, Rethinking Software Modernization in the Age of Generative AI. Posted on Forbes. It is a sponsored article, but anyhow, it has some interesting insights. I'll post the article also in the link of the post. What it says is that the core problem with the legacy systems is not so much the age, but the opacity. Nobody really knows how it works anymore. And it argues, or the author argues, that GenAI is a real value in the analysis of the code. And then it says using it to capture the intent of the old system before writing any new code. I know you're a skeptic on some of the AI applications, Kishan. What are your general thoughts on this in the sense of using Gen AI in the analysis and bringing the transparency in the code base, for example, or the application itself?
So it is a good point actually that he's making in this article, because in exploring legacy applications, most of the time of the development team goes into actually figuring out what someone tried to do. If there are unconventional parts of the software, we have to figure out why it would have been created that way. GenAI is, of course, it's a language model. And since code and comments are mostly language in the sense that it is trying to explain certain functionalities, it helps in quickly exploring not only the intent was, but why certain things have been done a certain way. Because, for example, there's a million ways to upload a file to a external storage. We have to figure out what the constraints were back then when the application was created to do it a certain way, to choose path A instead of path B, for example. GenAI doesn't explain that because it doesn't know the mind of the author, of the authors back then, but it can give us some kind of talking points. We can talk to the LLM about this code and ask why would these choices have been made, or we could point our own views into that and figure out whether they are valid or not. It's more about talking to it so you can understand it together. Because if it explains it to you, you don't necessarily understand it, just reads up what it thinks, and your understanding doesn't get any better from it. It's the same as if somebody reads a book to you, your understanding about what is actually being written is a lot less than you reading the book yourself. But reading together with somebody and talking about it, which is basically what you're doing, is giving you a different level of understanding about these things. So I think it's a good point that he's making, is that it can make your understanding and analysis about these legacy systems better. Because normally you would talk to colleagues, go through a code review, and then have an exchange of vision on what you saw and what your colleagues saw. The LLM is basically becoming your colleague then, but also doing it in a more efficient way.
And in practice, how does that look like when you would review an application and you have access to the code base and all the things that you need to review the application?
So the simplest way would just to put everything in and run it through an LLM like Claude or Gemini or OpenAI Codex. But the problem is that the context window is not that big. Gemini has the biggest, and I think Claude just released a bigger context window. But context, as we all know, lowers the more tokens you get into it. The understanding about the context lowers, and the things that happen in the beginning get a bit diluted once you get to the end of the context window. It kind of depends on the size of the application. If it's a smaller one, less than 500,000 lines of code, you could put that through an LLM. Well, 500,000 is pretty big, but I'm talking about with dependencies. So core code would be a lot less. If it's a bigger application with a lot of interconnectivity, we would do it piece by piece. Scope also the conversations that you're trying to have, and not try to understand the full application at once, but try to understand certain aspects, modules, or functionalities as a contained environment, have an understanding of all these small parts, and then trying to get a helicopter view of all these parts interconnected. Because there is no way to just point it to a code base and say, hey, explain to me all the different nuances that are there. It can probably do it pretty well for smaller code bases, but legacy systems usually aren't smaller code bases because they have been developed over many years.
Right. Yeah. Okay. And then, so the author also speaks about, to your point, about the different agents that he could use, like the architecture agent, the database agent, and the workflow agent, which then probably means that there is an LLM trained to give certain output. How does that work?
Agents are basically just a set of instructions given to an LLM without any other context. It's not necessarily trained on anything. It's more that it was prompted to do a very specific thing, as if you would prompt from the beginning that some LLM is a senior level expert in a certain field. These agents are prompted to be wary of a set of skills that they should have to do a very specific task. So you could say it's just very specific prompts and skill sets that are explained to the LLM that they should have to do a certain task. So for example, one of the skills or from a certain agent would be a expert level code reviewer in Python, for example, and a specific version. So the LLM would have context, hey, I would need to interpret these things as if it was an older Python version, and I would need to be the expert on this and also have the nuances of what the differences were between this old version and where we are now.
And what
So
would
it's
be
not
the
necessarily trained.
okay? And what would be the expected output for you as an architect or the senior developer on the project? What output are you expecting from the LLMs?
From my perspective, it's not necessarily output, it's the start of a conversation. I don't expect a list of, hey, this is wrong, this needs to be fixed, this is done in a certain way because reasons A, B, C. I would expect to have a starting point. You need to have a conversation about your own understanding of certain parts of the code. My usual way of going through this would be to explain my understanding about a piece of code and then telling the LLM or verifying with the LLM whether my assumptions are right, whether my understanding of the code is correct, or if there are any other entry points into a different part of understanding, or that I missed certain parts. It's basically fact checking my own assumptions without trying to bias it. The problem with LLMs is that the more you tell it, the more it's going to go into your direction. So it's finding a balance between you knowing what you know and still keeping the LLM critical of what you are telling it. Because some LLMs are very user optimistic in the sense that what you tell is usually the direction it's also going to go into.
Yeah.
Instead of critical thinking. There's no critical thinking, but not ignoring what you're saying, but trying to keep it as open-minded as possible.
And it seems like the way you are talking about this, of course, you are an expert in this field, but would it be also possible for people that maintain the legacy system? Probably they have also some experience in developing applications. It seems that they could also do this sort of analysis themselves already to maybe give a better briefing to an agency like Eli5, right?
Of course. They should be the subject matter experts because they are maintaining the system. They don't need to have many exploratory conversations with anyone, whether an LLM or a colleague, to have understanding why the system does what it does or why it was created a certain way. So you can point it into a better direction, especially when you're trying to refactor it yourself or trying to get somebody on board to refactor with you.
Good. Let's move to the next article that we have. So from a bullshit perspective, this article, how would you rate that?
I think it's a 7, 1 to 0 to 10, bullshit and low bullshit.
Let's review the article as like a number, as like 10 is best, 1 is worst.
I think it's 7. It makes some good points, but still, of course, the more you go to the end of the article, the more it goes into a sales pitch.
Well, I think it misses some of the practical application. How does it actually work? What does it actually do?
Because that's the sales pitch. You have to contact them to figure it out.
Yeah. Okay. So the next one, modernization legacy architectures using GenAI powered knowledge graphs. It's a mouthful. It is a nice article in a way that there are some visuals also. And it says, okay, this is traditional approach. And then you have the workflow for knowledge graphs. I'm not super familiar with knowledge graphs, so it was interesting to read the article and get some insights in this idea of using knowledge graphs. I see that the core of the article goes on into a visual representation and mapping dependencies and that kind of stuff. It also really splits different subjects. But if you could summarize the article or maybe give your first insights on the article, what do you like about it? Or did you get some new insights from it?
This is the same thing we usually do to get a very high level view of a certain application we get into or asked or have to be onboarded on, to view from very high level what is actually there. What are the dependencies? What are the connectivity? Is there anything very surface level it connects or communicates with? Then basically what it does, creating a graph of the application landscape, the infrastructure as it is, and all the different dependencies at that moment.
So is there a component of the LLM that creates a visual?
Most of them can do it right now. Almost all of them can create mermaid diagrams, which is a visualization tool that you can do from code to visualization. There are some that also can create just graphics, like the Gemini can just create graphics for you if you want to. I think Claude can as well. OpenAI also, but they have some issues with the the accuracy. The problem I have with this approach is that it doesn't give you any insights on why it got there. It's a snapshot of what is there now, which doesn't give you any idea of why it got there. In our work in creating, whether it's creating a new version of an application that is modern or upgrading small parts of an application to make it more modern, which is software modernization. The problem is not necessarily what is there now, it's why it got there. And this doesn't explain any of that. It's just snapshots and reviewing the snapshots and visualizing it, which is helpful in documentation and or in seeing what is there now. There is a reason why it was done a certain way, and that is just not explained at all here. It's just giving an insight into what is there now. And that's all it talks about.
Right. Okay. It has some interesting components that I think 8 or 9 applications to use the knowledge graphs on like use cases. I think it has a big overlap with the previous article as well, only now it has a different word. I'm wondering from your perspective, the hallucination of the LLMs, they need to analyze the code. They probably are not 100% accurate. How do you deal with that?
That's why I said previously, we have to scope the context. They just ignore certain parts of an application or don't check it because the LLM figures out what it needs to check by going through certain files, listing contents of certain files, but you don't know what it missed until you see the output. How do you tackle that? By going in small parts. So you still have an understanding of what it needs to check. You can verify that. And you can also point it to a better direction. Okay, you forgot that part. Let's fix this first and then move on to the next part of the application. If you are going to go to a code base that has more than 100 different dependencies, you won't be able to check all of them. So if you get a visualization that has more than 100 different floating parts in it or names in it, if it's a knowledge graph that just interconnects it all the way, the chance that you're going to figure out that something is missing is very low. So what I recommend is scope it, do it in small parts, and then combine them together in a later stage where you have validated that everything is there in the smaller parts.
So we're really into the back end or the code for the business rules in the code, but how do you combine the front end, the user experience with the analysis of the back end?
Can you clarify a little bit?
You could re-engineer or rebuild an application just by looking at the front end and seeing how it works. You can rebuild that from your own experience based on just what you see. You could also rebuild an application by looking at the back end and analyzing that and making sort of like, okay, we're going to build this because it worked like that. And now we have we can do that better with different code. And so the question that I have is, how would the front end analysis and maybe even the front end way of working in rebuilding applications match with the back end analysis? I probably know the answer, that it doesn't really exclude one of them to rebuild an application, but how you look at the front end analysis of things?
So the front end analysis of things gives a very narrow perspective of what is happening. You can create a new front end into existing backends a lot more simple than creating a new backend that integrates into everything. On a service level, the front end is the user facing. It only does what it needs to do, is allow the user to do certain actions or have certain features. You have no clue of what's happening in the background, what it's connected to, what systems it uses, what infrastructure it uses. So from a perspective of just rebuilding a front end, that is actually a lot more simple because you have only a very narrow scope to work with. You only need to make sure that the functionalities still work for the user.
I think the user in the end is the reason why the application exists, probably. And obviously, all kinds of analysis and processes happen in the backend that the user is not aware of.
Exactly.
I was just thinking about the 10, 15-year-old software. It grew organically, and now no one really knows how it works. But the front end is clear. The UX is not that beautiful and doesn't really work as it should in 2026, but you can see what the application needs to do without analyzing the spaghetti code. I was just wondering about the balance in that, but I think it's clear.
The only problem you're creating is that rebuilding the front end is not necessarily what anyone wants to do, making a new version of the front end. That is a completely different mindset, but also requires different things. You cannot just plug in the same features and functions in the same place. For example, a user onboarding has to be completely revamped and store other data. That also needs backend work. So you need to touch the backend as well. And that isn't a whole different minefield, mostly with legacy applications, because you have to touch old code in both parts to do these integrations. For example, if your onboarding also goes to a CRM or a certain sales system or a reporting dashboard, you have to keep all those things intact and updated to allow the business to have insights into what's happening. So it's not just touching the front end anymore. touching the front end is the starting point. You want a better user experience for your users to be onboarded, but it opens a whole can of worms that you need to fix in the backend to allow that.
It is sort of like renovating only the front end of your house and keeping all the crappy shit in the house as is.
Yeah, for example, if you want to build a new floor on top of it, you cannot do it when your foundation is shitty. So you need to attack your foundation then as well. That's the same thing we're talking about. We're trying to build a new floor on top of our house. But if the foundation, which is the backend, is not allowing us to do that, we need to attack that as well. And that is more costly and more intense to do because you need to figure out a whole different set of functionalities to be updated.
Clear. I'm going to ask a question, but probably this is for a later episode that we'll talk about exposing the data, the code base, and all the documentation. So, like very briefly, maybe already to sort of introduction to the next episode. Obviously, when you analyze, like use these LLMs to analyze code bases and documentation, the data is exposed, right?
Yes.
Or
if you use something like Claude Pro or Gemini Pro or OpenAI, I think I'm not sure. These plans that are personal, yes, your data is being used for training. That's why there are APIs to use where you have to believe them, of course, because in their terms of service, it says they won't use API sent invocations for training, which is what we also use. We only use the API. It is being sent somewhere, but you have to believe they don't do anything with it. It's a black box. You send it somewhere and they basically tell you, hey, we're not using it. And you have to either believe that or run your own LLM. The downside is that with current hardware prices, it's a lot steeper of a pricing curve to get into these things because the GPU prices just have gone through the roof if you compare to a year ago. And also prices and all the different hardware that basically allows an LLM to run efficiently are maybe 5 times as much as a year ago.
Yeah. Okay. This is interesting. I think for the next episode, using the LLMs to analyze these kinds of things will be a thing that will grow more and more. I think that is interesting to talk about next time from also security perspective, obviously security and privacy perspective. Did you get insights from this article? What would you rate it from the insight or bullshit meter? How do you like it?
It's not necessarily bullshit. There's not much substance there. So I think a 5.
Okay. Clear. Then we talked about 2 articles that mainly went into analysis of code, of architecture, of functions. And then there is also, it is actually quoted in one of the articles, an research that came out already a while ago from McKinsey, but it is used in one of the articles. And I saw something interesting in the article, in the research is like, it says something about the developer speed. Obviously, it mainly it is about senior developers that gain the most speed. Junior developers really don't understand what's happening and lose speed. It also says something about the complexity, where when the complexity is high, then the LLM actually contributes almost nothing. I think I've heard you talk about the context and the organizational knowledge that you need to analyze certain things. But what I wanted to ask you is this. It says something about the happiness of the developer or the developer experience. And it says about, like, I felt happy with using AI. It clearly increased the general happiness of developers when using GenAI. Do you feel the same way? And does your team feel the same way about that?
So happiness is a broad thing, right? But also the things that are working on need to be reflected in this. Generally, I think they are happier when using something that gives them immediate value. By setting up a new scaffold, for example, AI can do that very simply. You just have to wait and it sets it up for you. You just have to give it the correct pointers. There's no logic in there. It's just setting up things that usually took us quite some time. Writing boilerplate code, for example, took us time. We had snippets, we had to copy paste, or we had some shortcuts that we need to use. Now you can just ask for boilerplate code. That doesn't necessarily do anything, but it saves you time in writing these parts. For example, we used to have Copilot that completed these things. That's where it all started. And now it can generate these parts of the code for you in full, the files, the scaffolding, the dependencies that you basically need. So yes, it's a very big help. Also for documenting what you just made as a feature, or writing some boilerplate tests for you that you can refine further. All the lower level things are handled a lot quicker. For example, we just developed a plugin for one of our other companies. The scaffolding for this plugin was set up within a few minutes. Usually we would have to do all the scaffolding ourselves, do all the example files, do all the documentation about what we need to include. We didn't need to do that anymore. So that was a happy experience. The problem is, I think, this whole graph needs to be adjusted for the complexity of work that you are doing, but also the seniority level of the developer. A very senior developer that is knee deep into a very complex part of the code will probably not be as happy with the AI trying to help. You need to explain all these things to the AI before it has a complete understanding of what you're trying to do. It's missing all these business rules or context that you already had in your head because you're working on this part of code for more than a year, which is very different compared to scaffolding an MVP from scratch. The curve is very, I think I'm not sure what it's called. It goes like this. It's very helpful in the beginning. The more you go into the time and complexity, it just flattens.
The diminishing return.
Returns, yeah, because it really helps you in the beginning and it really helps with lower level tasks. The problem is what you're seeing right now is that normally a team of junior and senior developers would work together to do these things. The senior developer would delegate these simpler tasks to a lower level engineer to help them out. This is not being done anymore. The junior developers are not being taught certain things because once you set up this scaffolding, you would get additional tasks from the senior developer to add or change things in these projects, which also gave you an understanding of why certain things were being done, right? To have a million different ways of doing one task. The execution in a specific project is also explaining why you need to do it a certain way. Maybe there are compliance reasons, maybe there are infrastructural reasons, maybe there are contractual reasons that you need to do stuff a certain way because there is a vendor that has a framework agreement, for example. Just a very simple example. The LLM doesn't know that. It's also not going to figure it out for you. It just does whatever it is trained to do, which is GitHub and public code, which normally does it a very specific way because everyone does it that way. But that completely loses the nuance of doing it inside of a company that has different business rules. But also because of this shift, junior developers are not being hired. They are hired a lot less by these bigger companies. So they are not being trained to be the next meteor and senior developers that have been taught these different nuances.
We're not sure what kind of problems we'll give in the near future, but how do you...
It seems to be a big problem that is being created because the more junior developers I work with or talk to, or we get onboarded at Eli5, they have a understanding of the code that is fed by AI, as if you went to school and just did one thing all the time in one certain way. We have to teach them that there is not one way of doing things. There is 100,000 different ways of doing the same thing, but your job is to use your brains and your experience to pick the right way for that company or project. It's not something that will do the most common way.
This is an interesting topic we discussed a while ago. How do you get a senior position without being a junior? Time will tell how that will work out. People will probably be trained very specifically on things that current junior developers will not do anymore. There will be a middle way where people understand what's happening, but leave it to the LLM so they don't really understand how it works and then work on different things that also bring value. We will have to see what will happen.
Yeah, and that is a business risk, right? You identify the risk. Am I going to be reliant on an LLM to do the work for me? If you accept that risk, power to you. I just think it's a very difficult dependency because we don't know how long this runs. They are all being run by private companies that don't have any prerogative to keep them alive. So if you build your business around it, and Google, for example, is very happy to kill products that other businesses rely on. If they figure out that they don't want to do it anymore, they just say, hey, we sunset it after a year, your business is done. That is, you're very dependent on something that you do not control.
Well, luckily in the markets and capitalists will probably jump in and then provide a service that you can pay
Maybe
for.
if it's viable. The thing is, it needs to be viable, right? Right now, we see that money is being burned to run these things, which doesn't necessarily mean that it's viable. The viability needs to be there because if it just burns money, it doesn't earn any money net, so it will crash somewhere. How can we spend so much on data centers, hardware, power, and whatever is done to keep these LLMs alive, but also earn enough to keep that ecosystem alive?
Okay, so concluding this article, I think in general, or there is a research article, which is a bit older. I think mainly what you mentioned, focusing on satisfying and meaningful work more than without the LLM is a big thing, which was also in the article. So basically we don't have to review or rate this because it is just research, but when you would review it, what would you give it?
I think a 6.5 because of what I said about it not being adjusted for the type of work being done. saying that you're happy using an LLM in the beginning is maybe very different than if it starts working against you when you're doing more complex work. And if you just ask the question in the beginning, you have a very skewed way of looking at these things.
Okay, thanks. So nothing higher than a 7. We'll do better next time. Thanks, Kishan, for being on the episode.
Thanks, first.